This is the part where I usually say something along the lines of, you might want to draw this one out now because we're not going to come back to it very often. And while that is true, we're not going to come back to it very often. We're only working with the serial network in this particular lab. We're going to work more with Telnet and see how ACLs can help us tie down who can Telnet into a given router and who can't. So the only network we're dealing with here is the serial network 172.12.123.0/24, and we can ignore everything else. Now let's go up to router 1 first of all, and I just tested our connectivity there. Everything's fine, and everybody on the 172.12.123.0 network can ping everybody else on said network. Now we're going to configure router 1 for Telnet, and let's go to the VTY lines. We know that those 5 messages don't matter because we're going to set a password here, and let's use brewing. And privilege level 15, which I managed to misspell. It's really strange with that command because if you put priv level 15, it comes back and says, well, that's not enough. It's like, well, nothing else starts with priv. Anyway, so we're going with the password of brewing here in honor of the brewery that I'm looking at out my window here in Scotts Addition in Richmond, Virginia, where there's a brewery, a microbrewery on every corner. That's their plug for today. Now, we've got this all set up, and we know that users who telnet in are going to be put into enable mode immediately. They're not going to have to enter an enable secret or enable password, but we know we want to go ahead and test it before we start the meat of our lab, if you will. And there's the password prompt, and I'll log out once I'm into router 1, and everything's fine there. We'll go ahead and telnet from 3 as well. And everything's good. So everything looks good, and we're up on router 1 again now. We talked about this when we first looked at Telnet, that this one-size-fits-all password is not really a good idea because one way or the other, we know that password's getting passed around whether the intent is evil or not. And we talked about a username password database. We created one of those. There's a little more accountability there. But maybe we also want to tie access down by the source of the Telnet attempt. So what we'll do here is write an ACL that allows router 2 to telnet in from 172.12.123.2 and doesn't allow anyone else. Okay, let's go ahead and write that. The syntax is going to be pretty much what we expect. It's the application that's going to be a little bit different. I'm going to go with an extended ACL here. So extended ACL 101. And here we're going to do a permit since we're going to deny everybody else. And we do need to specify a protocol here that isn't IP because we're blocking or permitting telnet, so we need to go with TCP here, and then we're going to put in the usual source information. So there's our source, and we're going to put in host 172.12.123.2, and we're going to put any here for our destination. Any destination. Not quite done yet with this one though, because what we need to do is match on the Telnet port number, and when we're matching on any given port number, a specific one, we're going to use EQ here, short for equal, and that's the third choice from the top. And then we're given another great big list of choices. Now you can either put in the name of the protocol or the port number. And while the iOS help is going to give us a lot of common port numbers here, and I'll go ahead and hit the space bar so you see the rest of the list. Obviously, there are not 65,535 ports they're showing us. We're actually kind of glad of that. So if you know the port number, you can just use that option. You can also enter these words. And for Telnet, since we know the port number is 23, we can enter either one of those. It's another good reason to know, 23, 80, these kind of common port numbers, because you could see an ACL like this on the exam, and unless you know what port 23 is, you don't know what they're trying to do. We're just going to go ahead and put 23 here, and I could go with the implicit deny here, but I want to show you one reason that you might want to put an explicit deny at the end of your ACL. So let me do that here, and I'm going to do that for IP. And actually, I'll show you two reasons. We're going to discuss one, and we'll see the other one in action. And one reason is that you might be logging your matches. And what we would have to do here is set up a syslog device on the network, a system log server. and we would be sending these logs and these messages to that device. And you could inspect them later, especially it comes in handy if you're troubleshooting, you want to see everything that's going on. And that sounds great, right? It's like, well, let's log everything. Let's not. There's a reason that you don't see the word log at the end of every single access list on every single Cisco router you're ever going to work with. And that is that not only does it take up space on the syslog device for logs you may never look at, but logging is a real hit to the CPU. So it's not something we want to do just for fun. If we have a real need for these logs, we could go ahead and use that option, but otherwise we're not going to use it here. So that's one reason you might want to use an explicit deny, and I'll just go ahead and enter right there and show you the other one in just a moment. Let's do a show access list. And you see we're showing extended IP access list 101, and there are those sequence numbers again, 10 and 20. Those start with 10, increment by 10, and we are going to work with those later, but right now I want to concentrate on Telnet. And also note that we see the deny statement here. And of course, if we had just gone with the implicit deny and written a one-line ACL, not that there's anything wrong with that, we would not be seeing deny IP any. We also wouldn't see matches on that line. So this is another reason you may actually want to configure an explicit deny. So two good reasons overall so far, one of them being that we can send the logs to a syslog server if we want to, and secondly, even if we leave the log option out, it shows up in show access list and show IP access list, and we'll be able to see how many matches there are against each line. So with that in place, let's go ahead and apply it. And how exactly are we going to do that? Because we're not doing it on a physical interface. We know the command for that. We've seen it in action and we're going to see it again. But what do we put here? It's access, but not IP access group, anything like that. You need the access class command on the VTY lines. And then after that, everything's really the same. You're putting the number in, you're putting the direction of the connection, VRF also, we're saving that for way future studies, and that's it. So the proof is in the proverbial pudding, or the logical pudding in this case. Let's go ahead and telnet in. And from router 2, we were able to log in with no problem at all, and we expect that because that's the one that we're permitting. And we'll do a quick show IP access list here, and you'll probably see two matches there. You'll see that with a successful telnet connection. So far so good. Let's see what happens with our router 3. Wrong one. I knew I was going to do that sooner or later. That's our main address here. So let's try 1, and we are immediately refused. No reason is given. We don't want to give a reason, but we know the reason. We wrote the ACL, but we know now the ACL is successfully creating that block. And if we run show IP access list here, you'll see there is that one match on a denial. And if we had not put the explicit deny in, we wouldn't be able to watch those denies increment. Now, this is a fantastic way to block telnet access, but the thing is, along with blocking telnet access, and along with blocking anything, you may be in a situation where you want to block access to something some of the time, but not all of the time, or even permit it some of the time, but not all of the time. We can do that with the time range option with our ACLs, and we're going to use that along with restricting telnet access. We're going to get some more practice in with that, and that's coming up next.